Cohort. Okay, so welcome everyone. This is session 5 of 7. So I'll quickly put us through what we did last week. So we'll now quickly do some point and click instead of using command. Then we move to today's class, which is hypothesis testing and linear regression. So let's quickly, I sent us a file I sent to our mail. So please download it because we'll be using it. So this is last week class. Somebody is saying that I should start from beginning. Oh, okay. How do I do that fast? Okay, so I can use that opportunity to do point and click. So far so good what we have done. I will not open it that way. I'm closing everything. I open my starter. If it's point and click we want to do, let me close everything. When I want to use, I'll bring it. Okay, you open your starter. Now you can open file. You want to bring in your work. What do you want to open? I want to open this first file. Then I'll say open. Can we see? You see that it's totally different from that one, but it's still the same thing. You will get the same results. So the first thing we normally do is to browse, like we want to see what we are doing. So to browse, come to data and you see data editor. If you want to edit, let's say you want to start deleting, you want to start doing something, that's when you pick edit. And if it's you just want to browse through, you want to look at it, that's when you will click this browse. So let me do it now. This is browse. Instead of typing the command, you can browse through it and see. So you can do that. You can scroll up, down, and look at what you have in your file. So I'm done with this. I want to close it. So this same file, so that it will limit the editing that we do. So you can do data. Let's say you want to start dropping, you want to extract. So let me start from extracting. You come to this describe. You can describe data in the memory, like that one. Do you see? Say leave empty if it's for all. You can do this. Okay. Do you see? Instead of you typing this command describe, you can see that it is showing. So that's point and click for it. You want to browse, just go to data. You want to browse, go to data, describe data, and pick this one, describe data in the memory file. You click on it and it will give you all this. Now let's say you browse and you want to identify. You say, oh, I need S1, Q1, this one, that, like we did before. So now you want to start, you want to extract the one you need. You can come here, you go to this data editor, you click edit. Edit means maybe you want to start deleting, you want to start removing. So welcome, Mr. Olabisi. Okay, so you meet us well. We are starting from beginning using point and click. So you want to describe, you go to data and you say describe data and you pick describe data in the memory. So you click this one and it will give you. You can also inspect, you can list data. You can maybe like you want to describe the contents, this code file or this one, it will show. Just click on it. You want to summarize, you click this summarize statistic, but I'm still going there. Now let's say you want to start extracting the thing you need. You can come here. This data utility is where you label. You can do variable manager. This is where you will label your variable anyhow you want to give it name. You can create. Let's say all this generate that we normally do, you will use this create or change data. So I want to sort because I want to start yes, I want to sort. So when you click sort, standard sorting is in ascending. If you want it in descending, you pick this one. Let's leave it that way. Like the variable that you want to sort, which one? I want the, let me say HHID because I want to start if I sort by HHID, you see, you click OK. You see all this one that we normally write, instead of writing the code, I hope it's not, it's tiny, it's tiny.
It's actually tiny. I was about to say that.
It's tiny. I'm coming, I'll work on it now. Okay, so this is what is there. You see the describe that we did by point and click. You can see this is it, this is how it will come. So you can do point and click for that. So if I sort now, you can still go back and say you want to browse. We are not going to be writing. I'm removing, trying to make sure that I'm not writing. Okay, I want to browse. You come here and you say browse. So it will come like, you can see that it's sorted, right? It's sorted. Now all this our, and I want to keep, I want to drop some. Now you can use this one. The app is sorted, right? You can come here, data, okay, under create or change data, you can come here and say drop or keep observation. Drop or keep observation. So you can keep observation like this, and you put this express. Let's say I want to keep, if let's say individual is equal to 1. You see, this is keep if. It has deleted those ones that are not household head. If it's variable too, you can come here as if you want to do it manually. This editor, you can even use this one. Okay, I want to change mode, yes, because I'm in browse. Let's say this particular one, I want to delete it. You see, let me do it again. I will select this because I don't want to be doing it one after the other. I will select this row. Then on my keyboard, I will say delete. You see, are you sure you want to drop variable kinikon? Yes. Let's go back to see the command. Do you see? The command is there. This is drop respondent. So you can drop all these ones. Let's say I want to drop them. You can come here. There are so many ways to do it too.
I'm not seeing what you are doing.
Now, can you see?
No, your screen is like it's frozen. It's showing.
Is your network?
I'm at describe. It's my network. Okay. No problem.
Is that the Olabisi?
Yes.
Okay. This screen is too tiny for me. It's in now. How do I increase the screen? Okay. It should be around here now.
Can't you use your forefinger to zoom on the keyboard keyboard?
It's not working on STATA.
Oh, really?
But if I'm in that other output place, see this one now, this side, I can increase it.
Okay.
You see, I can increase this. You see this side is not allowing it. This side is scrolling up and down. Okay, so you can drop like that. You select whatever you want to drop under this edit, like this one now. I hope somebody is looking at that noise. This is how the recording will come out too. Prince. Welcome, sir. These people are distracting me. Mute for 8 hours. Yes. So you can select. That's if you want to do point and click. But to me, it's stressful. It's really stressful. So you can select like this. Select it and delete from your keyboard. All this, the do file, everything will be here. This is what you have done, and it's recording everything you are doing. If it's, let's say I want to sort, I don't want to write any command today, so I would say sort. I can sort maybe like for, let's say I want to delete those ones that are not okay. So I want to do that if, so I want to sort by zone. Good. I can come here, data, edit, come to edit. You see, maybe I want to keep only, I don't let's say I want to keep only, what's number 2, northeast. This is what I would do. You can select from here, select it and highlight the one you want to delete. It will still give us that command. That's my point. Just that if you use command, it's faster. You can use page down to make it faster. Okay. So the main point is this. Come in. I want us to see that if you do it one after the other, or you use command, you will still get the same results. Just that command is kind of faster. But what I did not realize is we are beginners. So I will do like this. I've selected what I want. I don't want that one. I will delete. You see, it's asking me, you want to drop 692 observation. I will say yes. So let's look at the command. So it will not be as if, what are we doing? Do you see? That's drop in 1 to 692, because you know that is where North Central is. The only thing you want to remain is just that number 2. So you come here again. The data is sorted, so no issue. I want to move fast. Okay. Page up. So I will start from where 3 is. Where is it? From here, 707. I'm going to highlight it because I want to delete others. Delete. Say yes. So let's go and look at it. You see, drop in 7072, the last one. So the only information that I have here is for those in the northeast. I don't want to type command. So you want to browse it. You come here and browse. So you can see now all of them. Where can you see this place? Northeast. So that is point and click for extraction. And you can also do if. Let's do if I want to sort this one now, this male and female. I want male to be up and female to be down, so that I can drop those that are. So you say sort, click data, go to sort. What do you want to sort? I want to sort S1 Q2. By now we should be familiar with it, right? So you say,
sorry. I don't know if other people are getting the same experience I'm getting. When you're doing point and click, you are faster than your mouse. Like, what your voice is coming like some seconds after you've clicked or something, or before you click, whichever way it is, but you're just faster than your mouse. I don't know if others are getting it as well.
Network.
Is that
network?
Mr. Teslim?
It's Jude.
It's
Mr.
your
Jude, okay.
network.
Okay, you see, they say it's your network. So I would try to at
Ah,
least calm down small. Do you get? You know, this one is just brief so that we know that there's no big deal there. So now, are we together? I don't know because I'm not in that side.
Yes,
So,
we are together.
okay, we are together.
I'm
Thank
not
you so
seeing
much.
what you are doing.
You are not seeing what I'm doing again.
I'm still
Oluwa.
at describe. I
Oh
am
yeah.
at describe. That's where my network froze.
Okay.
But I'm listening to you.
And I will slow down so that network will hear the word of God and listen to us. Okay. So let me know if the person that is saying that you are not where I am. When you are there, just give me go ahead. Just give me go ahead though.
Can go on, Mao.
Okay.
Can go on.
So I
I'm
want to
listening.
do drop all this one that we are saying, drop if, drop kinikon. You can come here. Don't forget there are many ways to do this. When I say change or create, you can do all this drop. So what do you want to drop? You can do if sex equals to. If you click this create too, you have option to write it here, inside here, and pick whatever you want to do and say okay. And you say, yeah, sorry. Do you see? All these things you experience because there's nothing like all this sex here. So that's a mistake. I supposed to rename first. Exit. Create. I'll come here. This. So there's nothing like sex. It's S1. So you write it S1 Q2. If is equals to 2. I hope I'm correct. Do you see? It will do. You can do point and click without writing command. That's the what I'm trying to say. Then which other one again? Which other one? Then we already know that after you can rename. Let's rename using point and click. I can go to variable manager and do that. Yes. Come now. Like this one now. This is zone. Let's go to S1 Q2. We use this one. Instead of this one, I can say sex. I can label it here. I can label it sex of respondent instead of command. Then in this place too, this is the value. I can change it. I can change it to sex, or you leave it if you still want it to be. Then I'll say apply. Has it changed? Let's look at it together. Can you see? I label
yes.
the label variable name S1Q2 to be this. Then I renamed. Do you see? I did not type the command though. This is rename, old name, new name. That's how to rename, abi. So we'll do the same thing like that. Then if you want to merge, we have been using point and click for that. You click here and you use combine data sets and you click merge two data sets like we used to do. Then you use one-on-one because I've put this one in in this place. That's where you have keep if individual equals to 1. I use that command that time. Then it's asking which one is the key variable that you want to use. I want to use HHID. You click what you want to use, then you browse to go and make sure you clean that other one too and merge it with whatever you want to do here. And that is all. So that's point and click. That's if you want to use it to clean. Now in the last class I already have the data. Which one is this? Close. Okay, let me open what we did last class.
Doctor, please, can I ask a question?
Please ask.
Yes. The error you just made over there,
Yes.
will that affect the results at the end?
No.
Or it will have no impact on? Okay.
Let me do it so you will know that kind of error. I will open this thing. That new one we used last week. Okay, this is it. This new data. So I will make that mistake again. Okay, this is the clean data that we have. I want to rename. It is that place that I want to rename. I want to create this. If you want to enter new this thing, you want to start typing in STATA, you can use create new variable. It will ask you what is the name. You will now put it. Let me say weight, like weight. Then specify the I can say that's I want it to be missing. The expression
Sorry,
equal missing.
sorry, please. Sorry,
Yeah.
can we open this new file now and leave the one we're doing before?
Can we open?
Like this new file that you just opened now. So can we also open this and pen the one we're doing before?
Yes, if we have, it's because of Mr. Teslim that say I should quickly run us through what we've done before. Who is the person asking question? Mr. Teslim, you are yes, because I have that one. I want us to practice what we did last week with point and click.
Okay. Thank
So
you.
that's how to clean. Whatever you do in this one, you will do it in that one that you want to merge. And you will go to data, you click combine data set, pick one to one, and make sure you use the key this thing, unique ID, which is HHID. I sent another one, another data. It's just for 30 responding. I sent it to our mail. So please download it if you have access to it now, because I'm tired of us saying HHID, and some people are not getting it. Let's look at other things. Okay, so I will use this one for last week class. Okay, now I want to drop this underscore merge. I'll do data. I want to drop. Which one do you want to drop? No, this is in between. I'll just go to data editor. This one I want to edit. I'll go to the last one and drop. I don't want to write any command. Delete. Are you sure you want to drop variable? Kinikon? Yes. Can you see the command? It has dropped. When I can easily write drop and I will pick that thing there. So that is it for what we did last week. Where's that last week notes? Okay, I noticed that the first one we want to do graph, bar graph, right? We did histogram for age. So come to graph, pick histogram. Which variable? You know, I mentioned that when you want to do histogram, like you are using it for continuous variable, so it's age. You click age. You can adjust all these things the way you want the width to be, like all those things. You say okay, it will load. So this is histogram. You can edit even in that place. Here, when you pick graph, histogram, so like all this labeling, you can put it, subtitle, the caption you want it. If you want to write notes, you can put it. You will just be saying okay. How do you want the y-axis to be? You can put title in the y. You can put for x. Then you click OK. As far as you have picked what you want to do here. I hope this point and click is much easier. Yes or no, please? Yes or no,
50-50.
I think
please?
both are okay.
50-50.
Yes, 50
Okay,
50.
50,
This,
but at
this,
least
this,
so at least I believe that when you pick, you know, there, like we have so many things here. Just explore. Now for this, who is this? Leave me alone. Like for, can somebody remind me? I mentioned that if you want to do summary, what do you get when you want to do summarize, and what are the type of what type of data will you summarize that will make sense? Can I summarize categorical variable? Anybody can try, please. Please.
Yes. I
Sorry, what
think
was the question?
it's meant for
I
number.
Okay. Like if you want to do something that makes sense, you want to take summary. What will summary give you? Like you want to summarize. Let me just remind us. It will give you the number
It's
of
meant
observation. It will tell you the minimum, the maximum, and it will tell you the average. So, what type of data will you use summary for? That's you want to create table.
categorical.
Okay, if I do summary of let's say for categorical where I have male and female. What will the mean be? What will be the mean? So for is numerical
It's
data
not
that we
for
use.
male and
We
female.
will use continuous variable.
Yes. So we
It's not
use
for male and
continue.
female.
Yes. So when you want
Yes.
to do that, you will come to statistics. You will click statistic, you click summary, stable and test. Okay, that's if you want to take, this one is for frequency, but if we want to take mean, minimum, maximum, and you also want to get standard deviation, you will click summaries, table and test. Okay, this one. Then you move to summary and descriptive, like all this one. Then what do you want to do? I want to take summary statistics. Then it's telling you that leave empty. If you want, is all that you want to do for, leave empty. Let me do this leave empty so we see. It will display standard one. This, I summarized too when I was telling us that you can summarize if you just want to look at it. So all this data now, I have 390, all of them complete. This is the average of zone, but you see that it's not making sense. I can't be interpreting average of zone, state, LGA, this one. Look at age. I can say, can somebody interpret this minimum age for me? Mr. Gabriel,
I'm with you, man.
can you interpret
It's
the
small,
mean age?
tiny.
Ah, God.
I can't
Mr.
say
Shegun
so.
that tamper with this laptop. Hey, I must edit this video. Okay. Oh God. Oh God. Okay, let me copy. Okay. If the mean age is this value, 53.85.
Mm-hmm.
So what is the interpretation?
That's the average age now.
Good. But for this sex now, this is the mean for sex. What is the meaning?
Shows that is the highest number.
Let's not
One is
stress
for
ourselves.
male now. One is for male.
Yes.
So so it's
Let's not
showing
stress
that
ourselves. It's not making sense. I can't be saying the
it's not
average
making sense.
age of sex is 1 point something. No. It's giving me 1 point because I have number. STATA can store both the code and the variable
Yes.
name, the categorical name. So if you want to do sum now, you want to do summary. For analysis I've started though. You come here. Let's not forget, if you want to keep your results, always use log. Click log. Log. This is the one I created last week. Let me see. 10. New log. It will tell me it has view existing file read only. Append. Okay, so you can append, like it will be by the bottom. And if I want to replace, I will do replace. Let me append. So this is through point and click, but you can see this is it will be under it. I will open it when we are done. Okay. So you describe under statistics, because it's summary that I want to do. You do this, you pick this, and you pick summary statistics. Then if it's okay, I have age. Age. Age is the only continuous variable that I have there. then I'll pick this. So it will show me age, the minimum, this one. So when you are doing your table, you can delete all this one if you don't need them. So that is point and click for summary statistic when you want to get the mean, minimum, maximum and standard deviation. Now let's do for frequency table. You know, we did descriptive statistics, then we moved to visualization. Visualization is when you are talking about graph, things you can quickly see from afar. And I mentioned that a good data analyst will not only look at table, it will also create something beautiful that people will be attracted to, which is graph. And that is the reason for calling it visualization, that's what people can see. All right, even though they can see table too, but you know, one will grab attention than the other. So let's do for frequency table. It is still table. So if you want to do for frequency table, you know that for frequency, what are we talking about? You want to get the count, then you want to talk about the percentage. So you come to it is still under statistics, summary table, then go to frequency table. Do you see? Which one do you want to do? I want to pick one way table, because it's just going to give me, I'm not comparing, we'll still use that one too. Now select the categorical, let me use sex for example. Okay, so it will give me, so you can see that majority of respondents are male, that is 82.82 of household age are male, which is normal in Africa, in Nigeria setting. Head of house here is always male. So this is the interpretation. What we have done is last week. So instead of us writing tabulate sex or tab sex, you can use command to get it. That is what we are driving, right? So which one? We did I think we did cross tab too. Yes, we did cross tabulation. Okay, if you want to do that, that will be two-way. Yes, because you want to compare two categorical variable. So I can do for sex and marital status. That's what we did last week. So you go to statistics. I hope my cursor is moving with my mouth now. Mr. Olabisi,
Yes.
is it working?
I'm seeing what you're doing. Yeah,
All
it's
right.
working now.
Okay. So I'll
I'm seeing
click
what you're doing.
statistics. Then you will pick this some okay. Okay. So you pick statistics, then go to summarize, like all the summaries table, and go to table. Is frequency table that I want to do, this one, but I want it to be two-way. You see, it's table, so you click two-way table with measure of association, because you want to look at the association between two. So which one do you want to be in the row? So I'm going to pick I want to check sex and this marital status. Did I claim marital status like this? It's supposed to be married and not married, but this is more than. Let me see. I will try it, but I know I have more than this thing inside. Wow, and it did. Okay, I have more than two. So this is tabulate sex marital status. This one is I'm comparing male and female with their marital status. So you can do this using point and click. This one is telling me that out of 2,346, this one is giving us frequency. It's giving us the frequency of this of these people. This is number, is frequency. If you want to do it in percentage, it will look rowdy. Then we'll be this is the one that is having higher, but we can still do that too. Let me try. Where is it? Frequency. God, the person that tamper with this my system. I'm just straining my eye. suppress the frequency. No, I want to pick percentage. List row in order of observation and frequency. Leave column observation. Treat. Let me go to option. Let me try this. I want percentage, but I don't know why. Okay, let me try. It's still giving me it's just using the weight to calculate. I want it to be in percentage, but I know if I still work on it later, I will tell us. So please, let's explore. This one is giving me frequency. I don't want to use and to calculate it. Then you'll be able to get just that all these 2, 4 and co, they will be giving us 0 point something. Which one do okay, we have done histogram. You will use it for numerical variable, and we have used age for that. So for graph, I think last week we were trying to do sex. We want to graph sex. This bar chart, there's something we did not click that last week. Okay, but can this thing just increase? Okay, so in this place we have main, and it's asking us type of data. If we choose graph of summary, it will be telling us the count. What we want to get is we want to look at the percentage. If you want to do frequency, this frequency will tell us the number. It will tell us the number. But if you want to choose the percentage, it will graph the percentage of frequency within category. This is it. Now you come to this category and pick what do you want to do. It's sex that I want to do. This sex that I want to graph. Then you say okay. Don't forget, you can come here to to edit how you want it to be. You can use this bar, like the way you want it to appear. All these ones are all these advanced. If you want to label, your y-axis, write what you want to write here. You want to give it title, write it here. Okay, so okay, let me go back to this so we'll see what I pick this one. Then for category sex that I want to do, then you pick graph. So this is it. How to do this graph. You can edit, you can give it another color if you don't want this color. So that is point and click for that one, and you can see it is still graph bar over. If it's do counts like we did last week, if you do counts like this, you should put all of them together. Okay, this place now is counting them. This is frequency, not percentage. So this is the graph for it, but depending on whatever you want to do, but it make more sense to use percentage. So you see visualization, you can, without you looking at number, you can easily see and say, oh, male are more than female. You can even see the gap. Then you can label it. Maybe like you want the number to show up, you want it to also show up here, you can do that. I hope we are getting it. Please let me get our response. Which one again? We do last.
Yes.
We are getting it,
Yes.
okay. Where do we stop? Oh. Okay, then the interpretation too. We did interpretation. So I think that is all. If you want to do frequency, you want to do cross tabulation, they are good for categorical variables. If you want to do histogram will do distribution. It will tell you how they are distributed across maybe like age group. And then summary statistics is always for numerical value. Then when you want to do all this bar, and you also want to do all these bar pie charts like this, so this is what I'm saying. That one to use to bring color, kind of. Okay, graph by category. Yes, let's see this. Okay, you see something like this. You see, like people can easily say and say, male are even more than this. You can edit or like that. So that is better. All this one you will use them for categorical variable. I believe we are clear on that. That is what we did last week. That is what we did last week. So please let's move to today's class. We can use the data that I sent to us. It's Excel. Okay, let me use that opportunity to yes. Let me use that opportunity to take us through. We want to use Excel now. We want to import. So please, if you have your data with you, let's use it.
Coach is hosting 11th edition of importation class. What do they do? Coach is a China importation school. They teach you how to import from China to Nigeria. They give you an
Somebody is
agent
on TikTok.
by so you like other
The
person.
prince.
Also,
Prince is in an hey, I almost closed this thing. Okay, so this is
Hello, man.
the well done,
Hello,
sir.
man.
Mr. Gabriel, are you calling me?
Yes, you said yes. You said we should open our starter. Are we going to continue from where we stopped on the uh, starter on this thing training last week, or we should open a separate data interface, that is starter interface?
Do you see what I sent to us? Like I sent a file to our email.
Okay, ma. Okay, is it that one that we should open, ma?
Yes, I'm thinking we should use another file. So if your client is giving you something, it will not be rigid. You'll be able to see. We can continue
Okay,
with this,
okay,
or we use Excel.
okay, ma. Either of the two, ma.
So and if you have this one, whatever the command is that we are typing, be using it there. Abi the point and click we are doing. Just make sure when we are using categorical variable, you are also using categorical variable. So that is it.
Okay.
Thank you so much. Okay. Yes, I want to import. So this is my file here. Now I want to bring in Excel. I think somebody should walk me through so that me I will keep quiet. Mr. Teslim. And he told me he's busy. Mr. Teslim, can you walk me through this? I want to bring in Excel.
So,
Okay,
so we'll go to file.
good. Thank you. Oh yeah.
So we'll go to import.
But
So I will
Okay.
see the Excel spreadsheet there. So I'll click on
Okay.
the Excel spreadsheet. I will browse.
Okay. This is what I sent to us. Okay.
Yeah.
Is that all?
So we'll browse the right file we want to put there. So we'll click on the import first row as a variable names.
Thank you.
Welcome.
Okay. So can we see? So I have this data here, and we have how many variables? We have 5 for 30 observation. So today we'll be talking about um hypothesis testing and regression analysis. So please, because this is a beginner class, for those that are familiar with what all this is, you just want to look at how it is on starter interface, please apology. So in this class we'll be looking at, I want us to understand the idea of hypothesis in research. Then we should look at the difference between null hypothesis and alternative hypothesis. Then we are going to conduct common statistical tests in STATA, and we'll be using point and click. God help us in Jesus name. I've been working with code for how many years now? Let's say three good years. I have do file, I just edit, bang bang bang, work gone. So no issue. So we are going to be doing point and click. Then we'll try to interpret p value, all the p-values. If we have come across any p-values, we must know it before we end this class. We must understand what p-values and confidence intervals means. Then when we are done with that, when we are clear, I'm not going to rush, then we move to how to interpret simple regression after running the analysis. Then we move to multiple regression. So is there anybody that can tell me the meaning of hypothesis? Anybody?
Okay, so basically, when you are talking about hypothesis, it's a tentative statement.
Good.
You want to project that maybe there is a significant relationship, maybe X has a significant effect on Y. So it's a projection that you are making ahead of your testing. So I call
Thank
it
you.
a tentative statement. Yes.
Thank you so much. I love that this thing, like the statement you are making ahead. Tentative statement. Okay, another person should try, please. When you say hypothesis, let me write it.
I can try.
Please try, sir.
Okay. To me, or previously, what I know as hypothesis in economics, or what I've done before, is simply a way of checking if some assumption about a data holds or something like
Yes.
that.
Thank you. Thank you. So we are saying the same thing in another way. God bless you. Thank you so much. Mr. Taufik, is he here?
I'm
I
here.
want to be sure that you are here. Do you know the meaning of hypothesis?
Yes, hypothesis.
Tell us.
Yeah,
You know the meaning.
hypothesis. Yes, ma.
Go ahead.
Hypothesis is just like how will I explain
Try.
it? Let me
Say it
put it
anyhow.
like a scientist. Sure.
Say it.
Hypothesis is like what you are still bringing. It's not yet a theory or law.
Good. Thank you. I understand the point you are trying to make. So something you want to test. We call it like
Yes,
a claim that is not being confirmed, is not tested. Thank you. You are correct.
yes, ma.
So thank you so much. Thank you, everyone. We Hypothesis is a claim about your data, because we are working with data now. Is a claim about, let's say, your business, because you believe that if I give people, let's say, if I give people 10% discount, I say, see, there won't be any difference, jare, people will not buy more, Joe. I will not make more profits. So it's an hypothesis. But in that case now, you see, I say, I can state it in the other way around. I say, if I give people discounts on my business, I will earn more. I will gain more profit. Do you get it? So we have two types of hypothesis. We have null hypothesis and null, like this. Can we see?
Yes, ma'am.
Okay, we have null and we have alternative. So we have null hypothesis and we have alternative hypothesis. So, for example, if from this data now, I've not checked this one, I say, men are older than women in this data set. If I say men are older than women in this data set, it is just a claim. I'm not sure. We have not confirmed if it's true or not. So that is us saying that is hypothesis. For what I think it's black. I don't know that person. I think it's black. Black mentioned that is maybe like you are trying to test something. For example, if people are working on, let's say, all this multicollinearity, because I noticed that people get to mix things up when they get to that part too. For example, you are saying that my analysis, like, there's no error. You are saying something like there's no error in my in my work, you have not checked, nobody has confirmed that. They are saying, oh, that you will see when people want to test, maybe they want to diagnose their work, they will say there is no multicollinearity. No multicollinearity. So that is still null hypothesis. Because when people now test and they now see that it is significant, they will say, man, if it's not significant, say, that means it's okay, it's okay. It means that there is multicollinearity, there's problem with what you have done. That is what it means. But I will not bore us with that. Let's start with the simple ones. So we'll start with the simple one. For example, the one that I just mentioned now, saying that there is no men are older than women in this data set. I'm saying that men are older than women in this data set. So that is a kind of hypothesis. So I will have null hypothesis to say that there is no difference. You know, I'm saying that men are older. I say no, there's no difference between them, Joe. They are the same thing. No different. So null hypothesis always come in form of no. You can say there's no significant difference, there's no effects. If government should start giving maybe like all these discounts, or let me call it subsidy, you are saying that there is no effect. No effect. So that no is a kind of null hypothesis. So there's no big deal there. I'm not going to overemphasize that. Okay, so let's proceed. We know what hypothesis is, and the alternative is going to be that there's difference. You can say there's difference or there's effect. It's going to affect. Okay, so and we have decision rule. Decision. Yes, we have decision rule that we normally follow, and that is us looking at p-value. P-value. When we run analysis, you will see what that p-value is, and I normally tell my students that please don't cram this p-value. You can have different significance level. We have 1%, 5%, and 10%. The common one that we normally use for significance level, for people in the medical line, they normally focus on 1%. What is the meaning of this 1%? What is allowed in their work is just 1% error. 1% error. You know, they deal with human being. You can't just be killing people anyhow. So 1% error, it is what is allowed in their work. But for social scientists, other this thing, we move to at least say 5% is still okay. Some people go as far as saying 10%, but the normal one that you will see is that 5%. That is the common one. So the common rule is that if your p-value is less than 0.05, that means there is significant difference. So you have to reject the null hypothesis. I hope I'm not speaking too much grammar. Can I come again?
Yes,
Please, ma,
please
come again, please.
All right. So I will come again. Maybe I will write it. We have p-value. P-value. The rule is that p should be less than 0.05. If it's less than 0.05, we'll reject the null hypothesis. Wait, maybe I even have notes that I can easily show us. I'm coming. Maybe I did not put it on this system. I'm sorry, your family.
Send us the note.
I'll
Send us the note.
Okay. I like to put it in good structure. Okay, let me open this. Yes, I can use this to even teach us because I have it here. That way I will not waste time. Instead of typing out okay. Baba God, I need this thing to zoom. Yes. Okay, so this is what we've been doing, and this is what I've been saying. Hypothesis is a claim about your data. Example is when you say men are older than women in this data set, and you have null hypothesis is always like this. I wish I can color it. Can I bold it? It's not working. So you will state the null hypothesis like this, saying that is always, this is how they normally write it, just in case you come across it. We say that there is no difference. There's no difference between, now what you are saying is there's no difference between men and women. Their age is the same thing. That's what null hypothesis is saying. Alternative is saying that there is difference. That means maybe women will be, they are on average they will be older than men, or men will be older. That is what alternative hypothesis is saying. There's something we call one way, two way, but let's leave it that way. The null hypothesis is saying no difference. Alternative is saying there's difference. So this is the way they like measure if there's impact or there's effect or not. So no issue. We have decision rule. You see this p-value. P-value less than 0.05. You will reject the null hypothesis. You know the null hypothesis says there is no difference. If the p-value you are getting is 0.05, then you have to reject the null hypothesis. That means there is significant effect or difference. Then for p-value that is greater than or equals to 0.05, you will fail to reject the null hypothesis. Okay, that means there is no evidence to prove that men are older than women. Okay, this is what I normally use. It's greater than, because if it's equal to, greater than or equals to. Now this p-value, I do tell students, like, don't cram it. How do we get this p-value? Please, this p-value is talking about 5%. Can somebody take calculate 5%? 5% is what?
0.05.
So please, let's not cram it. You want to know, like, okay, is my work statistically significant at 5% or not? So that is where this 0.05 is coming. And for those in the medical line, I explained to us that their own is what? 1%. Can somebody take 1% and let's see?
0.01.
0.01. So the p-value must be less than or equal to, Now, before we move forward, if I have the p-value, my p-value, if it's let's say the p-value is equal to 0.051, is this thing significant or not? Anybody answer.
It's not significant.
At what percent?
It's not significant, yes.
At what percent?
It's more than 0.05. It's more than 5%.
Because of the one.
Thank you. So please, we are not cramming it. We are not. It is not significant. That means there's no there's no evidence to prove that men are older than women. So we'll do what? We don't say we reject. We say we fail to reject. Everybody, please look at it. We are not going to say we accept the null hypothesis. They don't say that. When you are interpreting your result, we say we fail to reject. We fail to reject the null hypothesis. So is it clear? If the p-value is less than or equal to 0.05, that means there is there is significant effect or difference. But if the p-value is greater than 0.05, for example, if you have 0.051, what will you say? You fail to reject the null hypothesis. That means the null hypothesis is correct. That means men are older than women. But we don't say that. We say we fail to reject instead of saying we accept. Can I move forward? Somebody should give me a sign that I can move forward.
Yes,
Yes,
ma. Yes,
please.
ma.
Yes, you
Thank you so much. Yes. So let's start analyzing our work. Okay, what's it? I even put the part here. Okay, now we have, I'm going to see how this thing tiny. Stop complaining, Kwemi.
We can zoom on our screen.
You
We can
can
zoom
zoom,
on our
right?
screen.
Thank you. Thank you. Please
Yes,
do
in
that for
that
me.
upper hemisphere yes, you can press zoom in, zoom out.
Oh, thank you. So everybody, please try to zoom so you can see. Okay, so we are going to be using point and click to do what we want to do. We want to test. Okay, we can browse, right? Somebody should walk me through how to use point and click to browse. Prince Ibe, are you there? Prince, yes, Prince. The Prince.
Hello.
Hi, welcome. Oh yeah, walk me through how to. I want to use point and click and not command. I want which one is this? There's nothing here. No, this is not the work. Oh. Okay, this is our data. So Prince, I want you to walk me through. I want to browse. I want to know what is in here. I don't understand the data. It's new. We've imported the data. I want to look at it, and I don't want to use command. If I want to use command, I will just type browse, and it will bring me the data. I will look at how it is, but I don't want to. I want to use point and click. Can you help us? If
No, I
if
can.
if you don't know, it's just
No, I cannot help.
you join late.
Can
You will
I
pay fine.
can I
can
try?
help.
Oh yeah, somebody
Can I
should
try,
try.
ma?
Anybody? Yes, sir.
You go to data.
I can
Yes.
help. I can
Okay.
help.
You go to
Okay. One.
data.
Okay.
Okay.
From data, you navigate to data editor.
Okay.
Then
Which one?
data editor. Then you navigate to data editor browse.
Browse. Yes.
So do you see? Instead of writing command, if you do not remember command, just do point and click. So it's done, right? So that is how to do it. So for hypothesis testing, we want to test now the null hypothesis. When we have one sample t-test and we have two sample t-tests. One sample t-test and two sample t-test. You see, for t-test, you will use it to compare for one sample t-test, like you want to look at mean, average. We want to look at average, like that example that we just mentioned now. We mentioned that men are older than women in this data set. That is what we are assuming, but the null hypothesis we state is that there's no difference between them. Like on average they are the same age, jare. On average they are the same age. So we want to test that. So you will use one sample t-test. If the mean of one variable is equal to a specific value, for example, somebody can come and say on average their age, all these people, their age should not be more than, let's say, 30. Like on average 30. So you will use one sample t-test if you already know, like you have a number that you want to compare it with, or somebody is saying that the people in this training on average they are small child now. All these people, they are very small children are the one there now. On average their age should not be more than 25. So that means if we have somebody that is maybe like 45 among them, then we have 15, we have 12, we have 35. So when you take their age, they should not be more than 25. So that's like a kind of a claim. So now we will use one sample t-test. So we will set that we are saying that the average age of these people is 30. Let me summarize. Oh, I don't want to write command. Oh, I want to summarize this data. Oh. Can somebody please help me? Where will I go to? I want to summarize. Is it file, edit,
Please let,
graph?
Static.
please let us see your screen. Your screen.
Ah,
Come on.
my screen is showing.
Uh,
You want to
I'm only
summarize?
seeing
Just
the command. The command. This.
Is your network? Can
Oh
you
my God.
refresh?
Okay.
Who else is seeing command?
I'm seeing command too.
You are seeing command. Ah, is it my network?
Mm-hmm.
Oh, yeah, let me. What about now? What can you see?
I'm
yes,
seeing
yes.
summarize. Okay.
You
Yeah, I'm
open
seeing it now.
something else.
Is it
Open
working now?
statistics.
Yeah, yeah.
Yes,
Thank
ma'am.
you.
Yeah,
Okay.
it's working.
Okay. It's because I didn't scroll down.
Uh-huh. Okay, so I'll click summarize. See, point and click is good because if you think it's supposed to be in graph and it's not in graph, say, oh, is this one Jerry? So you click summarize, then go to table. You go to summarize, then you look for that table. Okay, no, come because it's me. Oluwa, open my eyes.
Summarize
Like
statistical.
you do because this is starter 17. So please, if you are using, and now we have starter 19. If it's missing, it's not, the parts has changed, just look for that thing that you are looking for. This is summarize table and test. I'm looking for classical test of hypothesis. I want to test hypothesis, and this is what I
Okay.
want to do. It is the t-test that I want to do. I want to compare the mean. This is a known variance, so we call it known. Hey, I hope I'm not speaking too much now. This is known because I know what I want to compare it with. We call it known. If you don't know it, instead of using t, we use z. So which variable do you want to compare? Is the age we are talking about, abi? You select age. What is that hypothesized mean that you want to compare them with? We are saying that maybe they are 30 on average. Then you say okay. This is the results. Again. This is the results. So let's pay attention, please. This is where my my colleague says, see, this one, I am still trying to understand and know, but I say calm down, nothing is there. So for this t-test, if I want to write command, this is the command I will write. I will say t-test age equal 3 and 30. That is, I want to confirm that their mean age should be 30. So forget this because we've used
Can't
point
one
and
just stick to point and click?
I'm not running it, I'm just telling us. Okay,
One
so
can stick to point and click.
yes, sir.
One can
Hello,
stick to
ma'am.
point and click in his work.
Yes.
Okay.
Hello, ma'am.
Yes, sir.
Yes, please. Under that point and click, after you click on that, the last dialog that shows the text and main comparison text, you first click on the one sample, then under the variable name, you click on the age. Under the hypothesis main, what did you click there?
I put 30.
30. Okay.
I put 30 because I want to test that there is no, like, their age is 30. That I'm saying that there's no difference between, on average they are 30. Like, that's what I'm saying. Now this is the interpretation. Look at age. Observation we have is 30. You have the mean. On average, these people, their mean age is 29.933. This is standard deviation, this is standard errors, this is standard deviation. No wahala abi. Now, this is the mean age. This is what we have done. This is the null hypothesis is here. Can you see my, please zoom out so that you see what I put there,
Yes.
that I say that is 30, right? Equal 30.
Yes, ma'am.
See, look at it. This is alternative, abi. You know, I explained to us that the alternative is written like this. You see, H1, H0. They can also write it HA, depending on who is doing the work. Good. Okay, it's even good. I even have it here. You see, when you do statistic summarize table, click this, then look for classical test of hypothesis, then click one sample mean test, or depending on the one you are using. Where is the one we are working on? Come here. So I click statistics, summarize. You see, instead of me to go and look for it here, it's already here. Are we together? So I click
Yes,
this,
ma'am.
then I move to this. I want to compare mean. I now click this. You see one sample? That is what I want to do. One sample. Which variable did I want to compare? I want to compare is age I'm talking about. What is the hypothesized mean? Is 30. If it's 25, we'll say 25. And we'll say, okay. I've done 2 analysis now. Now, please, let's interpret this.
How do you know it's 30?
It's under assumption. Like maybe somebody is making a claim saying that on average, their mean age is 25. It will be given. That is why we call it known. For t-test, if you want to do sample t-test, one of the assumption is that you know the hypothesized mean. You are comparing it with, maybe you are expecting that their income should not be more than 100,000. So it is known. You now want to test. Is it true that on average their income is this? Is it true that on average their age is this? Can we move on to interpretation?
Yes, please.
Okay, thank you. So this is the first one. One sample t-test. So just in case somebody should run analysis for you and you are seeing, because this is what they will send to you. They will send the log file. You are the one to clean it. If you don't need this observation, you delete the table, then you have the mean. Now, this is our P. When they are talking about the probability of the T tabulated and the T calculated, this is the T calculated and the T tabulated is this 30. When you now look at it, this is the P value. This is the probability. P, probability equal to 0.47. Can somebody tell me, this one is measuring that the mean is less than 30. The mean is equal to 30. The mean is greater than 30. For this one, let's say it's, I don't want to explain one two tail and one tail. Is there somebody that know about one tail and two tail here? Test of hypothesis. One tail, two tail. So I'm going to be silent about it. But if you look at this P value, let's say we are saying that they are less than 30, their age is less than 30. This P value is what you will know. Is this P value significant or not? 0. Let me copy it and put here so it will be big.
It's significant now.
Is it significant? Is
Yes.
it significant?
Yes.
It is.
Eh?
It is. Yes.
At what level? Is that Daddy Adebisi or Labisi?
Yes.
At what level, Daddy?
I don't understand what you mean by level. Though.
Okay. Another person, please. Mr. Morris.
Yes, it's significant at 5% significant level.
Okay.
This is about 47%, 40 something percent.
So is it significant?
It is significant.
Yes, I think it's significant.
It's significant, man.
What is the decision rule?
Okay.
It's more than 5%.
What is the? Oh, I know it's more than 5%. What is the decision rule?
Fail to
reject.
No. Let's look at it. We
no
are
evidence.
cramming it like that. The decision rule is this, Abi. Let's focus on this one. I want us to
Yes,
get
ma'am.
it.
It failed to
please.
reject fail to reject. No
So it's
evidence
true.
of
The value is
The value is less or equal to 5%. We reject the hypothesis, but if it is greater, we fail to reject the hypothesis, meaning we accept it.
Let me copy and bring the. Hey, what have you done? I don't want us to cram it. This one is us taking theory, but I have to explain this theory. The decision rule is that if p-value is less than or equal to 0.05, I have to copy this thing to this place because we'll be using it to. Let's not cram it though. You must know it today by fire by thunder. Okay, good. Madam Miriam, is she there?
I'm here.
Uh-huh. What of Madam Jennifer?
I'm here.
Uh-huh. Mama, you interpret too. Uh-huh. Let me put comma here so it will not stress us. I want it to come to another place. Good. Let's focus on this. The decision rule is that if p-value is less than or equal to 0.05, we will reject the null hypothesis that there is no difference between their mean age and 30. We will reject. You know, he's saying that there's no difference, we will reject. But if p-value is greater than 0.05, we fail to reject the null hypothesis. That means truly there's no difference between them. Let's look at this p-value. Is 0.47. Is it greater than or less than 0.05?
It's greater than.
So what are we
It's
going
greater.
to do?
We fail to reject the null hypothesis.
Please, that is the we are going to reject. We fail to reject. We are failing to reject because truly, this thing is saying 47%.
Yes.
That means you are saying that you want to reject null hypothesis and you want to consider 47% error. I don't know if somebody is getting this my explanation.
I think
Yes.
0.47 is less than 0.05. So what am I saying? Oh, sorry.
No.
Yeah.
No.
It's
Yeah,
more.
yeah.
It's more.
It's more.
It's more. Sorry, I got it wrong.
47% is more.
Yeah, it's
47% is big. In
Yeah.
fact, there's no statistical significant level for this. Is either it is 0.001. This is 1%, Abi.
Yeah.
Which can be anything that is less than is 0. If it's less than, that means it can be 0.00001. It is significant at 1%.
Evidence.
That means there's strong evidence.
Closer to
0.01 strong evidence.
That means it must be is either it is equal to this is 0.01 or is less than. So if it's increased and this one now is now 2, if it's 2, is it significant or not?
This is significant.
Thank you. It is significant. At what level?
At 5%.
Thank you. Because
2%.
it is no longer significant at 1%. The next thing is 0.05 because it is less than 0.05. So 1% cannot accommodate it again. It has moved to 5%. So are we good?
Yes.
Kind of.
So thank you. So now I want to give us Orijo. You too, you can look at it like this. The mean age is 29.93. We are comparing it with 30. And the null hypothesis is that there is no difference. When you look at it, is there difference truly? But you know, we cannot say it with our mouths and say, because 29 and 29.9, that's almost 30. But this is very obvious that they are the same thing. So statistically, we still want to know, because you cannot just use mouth. And that person can say, I'm getting 28. 28 is not far from this. And that is why we normally talk about statistically significant or not. So for this now, for this, when your p-value is proving to you that it's 0.49, it's not significant at any level. It's not significant at 1%, not significant at 2, not significant even at 5 and 10. This is it. So if you move to this place too, the alternative hypothesis is that their mean age is 30. So this one too is not still significant. This is still not significant. So there's no significant difference between the hypothesized age and their mean age. So for that one, remember that I tried to use 25. Let's assume that it's 25 they gave us. The analysis did not change because you are still having your mean. The mean is still the same thing. You are comparing it with 25 now. So can somebody tell me, is it less than 25? Is this age, is it less than 25?
You fail to reject.
Okay. Hold on, before we conclude. Okay, we've explained this first one. I want to remove it. Now, if our p-value is 1, the p-value is 1 on the dot. Let me remove this too so it will not confuse us. The p-value is 1. Is there a difference between the mean age and the mean age? This is 29.93 and the hypothesized to be 25. Is there a difference?
No.
No difference.
Yes.
A p-value of 1 is
Is it significant?
It's not significant.
Yes.
It's not.
It's significant.
Yes, it is.
At what percent?
At 10%.
Somebody should calculate 10%. 10% is 0.1.
Oh no. This is 100%. This is 100%.
It is not significant.
Not significant.
It is not significant.
So it is not significant, please, because this number is greater than 0 point. You see?
Reject. Fail to reject.
You know, this one is when it is significant. This one significant.
Okay.
Let's put it that way.
Okay, if it is less than significant, okay. Okay.
It's in the note, but it's important to understand it here before we leave.
Once it's greater than this is why I do my own. I don't know. Once it's greater than 0.005. Once it's above,
not significant.
Having one. Forget the 0.00. It is above.
This is 100%, so it's not significant.
I was kind of wondering. Yeah. So good.
So because we are going to use it to explain another thing, not significant.
We failed to reject.
We failed to reject.
Reject. It's my Igbo tongue.
What about my own? My Yoruba? I beg, we have to move on.
No comment.
No comment. So no comments, please. So this, but look at this one. This is alternative. We are saying that the mean is equal to 25. For this one now, is it significant or not?
It is significant.
So what are we going to say to this now?
Reject HO.
Exactly.
That means when you say and there's no their mean age is 25, you say no, there's difference. Because it's saying that there's no difference. You are saying that there's no difference between 25 and 29.93. So this is already proving
There is
that
difference.
there's difference. So we are good, right? So we'll do what?
Yes.
We are going to
Yes.
reject the null hypothesis that there's difference. So you can't 25 is cannot be compared with that. Can we move forward?
Yes.
Yes, ma'am.
Yes, ma'am.
Thank you.
Yes.
I want Madam Jennifer to talk. Okay, so we have explained this. This is the one we finish. One sample, that is, you have average age to be equals to 30. That is what they are saying. So the null hypothesis is that no, there's no difference between the mean average age and 30. Why the alternative is saying that there's difference. So when we test the one that says is equal to 30, we notice that it is not significant. So we fail to reject the null hypothesis, saying that there's no difference. So we fail to reject the null hypothesis. So we have done this, and the interpretation is that if the p-value is less than 0.05, then the average age is significantly different from 30. But what we got is actually greater than we got 0.47. That means there's no significant difference truly. We hypothesize another value, we say 25, and we notice that there's actually significant difference because the hypothesized age is greater than 25, is statistically greater than 25. So we have two sample t-tests. We call it independent t-test. So please, next time you come across things like this, don't let it be strange. When are we using two sample t-test? It is when you want to compare the means between two groups. You want to look at the average. You want to look at, the first one, we generalize it and we are comparing it with a particular number. But this one, we have two groups. We have men and women. And we want to compare their mean age. So this one now is two sample. They are not depending on each other. So let's go and do this. We'll go to statistics, summaries, summaries, tables and tests. Then click classical test of hypothesis. Then choose two sample mean. Let's go and do it. So that means we'll be comparing the age with sex. So
Sorry,
let's go.
just a little clarification. You said two sample tests. When do we actually make use of that? Can you repeat one more time?
This is it. You are going to use it when you want to compare the means between two groups. That means
Okay.
the mean average age of men, you will take it. The average age of women, you have it. Then you compare. So it's something that one can do manually, but who will go through that when you have 28,000 respondents? So we are just using this 30 so that it will be handy. We'll be able to do it. So let's take the parts. Can somebody walk me through how to do it? There's no wrong or correct answer. I mean, there's no wrong answer. We can only do it again if you did not get it. So, where should I go to? Let me be clicking it so that we'll know. What should I pick?
Graphics. Statistics, sorry.
Okay.
Summary table test.
Okay. Which one?
Classical test of hypothesis.
Okay. Which one?
This was I didn't get this one.
Okay, so I'm going to click classical test of hypothesis. I know it's inside this one. It's inside here. This is where I will pick whether it's two that I want to do. Two
Two
sample
sample.
group. Yes. So I want to compare the age,
Age.
then the variable, the group.
B
Group variable name. What is the
is
group?
sex.
So I'll say okay. Okay.
Man, the good variable name, what did you put there, man?
What did I put? I put
Inside the
sex.
group. Okay, man. And the variable name.
The variable name is age.
Okay, man.
Thank you so much.
Sorry, I think I missed something.
Let's
From
do it
the
again.
classic, from the classical test of hypothesis, where do you navigate to again?
The T, that one that we used that time.
Oh,
Are you getting it? When you now click,
yes.
you see we have one
Instead of
sample.
one,
We
use
use
two.
one sample that time.
Yeah, two.
This time out.
This
Sample.
time we want to compare two groups.
But why is my table showing the uh, A, B, C, D?
Maybe when you import. Okay, can somebody tell me why? Why is who is that person? Is it that the
My
Labisi?
my variable is showing A, B, C alphabetical.
Somebody should
For
explain what happened. Mr. The Prince, Madam Jennifer. Where's Mama Jingle? Where's Mama? Ah, is it network? Network. Okay,
was
Mama
it
is here.
was it when I was importing?
Yes. That's Daddy Olabisi Abi.
Yes,
And you did not click something when you were. Let me quickly show you.
when I was importing. Okay,
So here, when you do file, import, you pick
okay,
this. When you browse and you bring it to display, you do not click this. Import
okay,
first row
okay.
as variable names. That's why.
Variable names.
So
Okay, thank you.
do it, sir.
Okay, thank you.
Any other question?
Yeah,
Please
yeah.
ask your question.
Okay, on the group variables, is it still 25?
Ah,
Group
we have moved to
variable,
independent now.
huh?
You will change it. This is what you did not change. See, is that black? Black.
Yeah, yes,
When you click classical test of hypothesis, you pick T test. If you click on one sample, but what you want to do is not one sample. You want to
two.
compare men and women, their mean age. So
Mm,
it's two sample using group.
okay. Oh, I see.
Thank you. Yeah, let's do it.
Now, I want to ask a question about that confidence level. Can we change it?
And you can change, but we are using 95. 95% is what is all journals. 95% confidence level. So don't change it.
Okay.
Okay, and it's fine. Okay.
Hmm. So are we all there? Is Daddy Olabisi with us?
Yes, I'm there.
Do you get it now?
I'm there. Yes, I got it. It's
Good.
corrected now.
Mhm.
Supposed to have the same figures as yours.
And we're supposed to. Maybe we are using the same data.
Yes,
Okay.
it's the same thing.
Okay.
0.3099 and 0.8450.
Okay, you.
Yeah. I'm not seeing no. Where is it this one? This interval, right?
It yeah, the last one, like the how would I say it?
The differences.
Value, P
Less
value,
than zero.
Yeah,
P
yeah.
value.
Why is
The
our
p-value
p-value
there.
different?
No, it's not different though.
It can be
Different too.
different.
It's
It's
different.
not different.
It's not
No, it's not
different though.
different. It's not different.
It's not
It's the same.
different. It's the
Zero
same thing.
point eight four five zero.
That's zero.
Then the first one is 0.3099 and 0.31550. So
Okay. So, because we have one way and two way. If we are talking about one way, you can say like you are not focusing on any direction, but if you want to look at it in two way, is it that you are saying that they are less than, they are greater than, that's why you are having this. So we are focusing here, saying that there is no difference. This one is the same thing we did here. If you notice, this is what we pick. So
mm,
let me break this table so that we will not be scared of it, please. You know we have two groups, abi? We have group one and
Yes.
group two. It's
Yes.
sex. So the reason I have it like this is because, let me browse it. Hey, I'm so used to that command there. Okay, look at sex. We have one two one two. We do not specify which one is male, which one is female, but you know we can use this small file like this to repeat everything that I've taught us. When I say you can rename, you can recode, and write how you can label it, and this is point and click to do that. Let me not deviate. So one is male, two is female. Now the number of observation, how many male do I have? I have 15. How many female? I have 15. When you get another data, it will not be like this. You can have male to be 12. You can have female to be let's say 18. You will still get combined effect. No issue, right? There's no any issue here. Now look at mean. The mean age for one, which is male, is 28.86. That's their average age. For women, their mean age is what? Somebody should tell me. Madam Jennifer.
27.
Madam, I want to hear Mama Jennifer speak. I'm on your case. Mama, Madam Jennifer, is she cooking? Shall I send my own? Mama, where is she? Ah,
I
Jesus is
think
good.
it's a network.
No, Mama is busy. Okay, no problem. So the mean age for this group of people, we call them female, two female, is 31. So what we are testing is, and this is the combine, you can see combine, they are 30. Generally on average they are 29. The same thing here when we have them general, but this time around we are comparing the two. We want to know the difference between the mean age of male and female, and the hypothesis is that, the null hypothesis is that there's no there's no difference, no difference. Now we will use the p-value to interpret, is there difference or not?
the p value.
Is it significant?
Not significant. Not.
So do we all agree that there's no significant difference between them?
Yeah.
Yes.
So what is going to be our decision?
Fail to reject.
Fail to
It's not.
HO.
Thank you. So now we know the interpretation, and I'm happy. God bless you.
Yeah.
So there's no difference. What's the next thing? There's another test that is yes. You know we can also compare, we can do two tests when we want to
test.
compare. Let's compare the income of male and female. Somebody should help me. I want to compare the income of male and female. Where do I go?
Income.
Because we have age, we have sex, and we have income here. Can we compare income of male and female?
Yes.
Oh yeah, guide me.
Go to statistics.
Okay.
That's got test.
Summaries, tables, and tests. Tests. And
Classical test.
Classical test of hypothesis.
Thank you.
Test mean comparison test.
Okay. So what am I going to put here?
Two sample in this place you put
two samples.
Okay, I
one
click
sample.
two sample. Is it one or two?
Two samples, yeah.
Two samples.
It's two
Okay,
samples
two.
because I want to compare the average income of male and female. So it's
two samples using variables.
Okay. It's group I want to use.
It's group, okay.
Oh yeah. What am I going to put in the variable name?
Income.
It's income.
Income.
I don't want us to cram. You will see group here. Group variable name. This is where you now put the one that have group. You know, this income is just number, no group. We do not categorize it. If we categorize, we will see something. Oh yeah. In this place,
Can I ask a question?
Variable name.
Can I ask a question?
I'm coming, sir. Let's run this one. Or is it here? Is it on this one that I want to
Yes,
do?
on that. Why is this confidence level set at 95?
That is the basic one.
Okay.
Because we are using 5% significance level.
Okay, I get it now. Thank you.
Thank you, sir. So
But
can I click
variable name and the
Sir?
Yes, under the variable name we should put income.
Okay, I put income.
Then under the group variable name, we should put income as well.
We should put income.
Is it income or sex?
It's sex. We want to compare the income, average income of male and female. So we are going to put sex.
Okay.
Because that's where male and female is. We know gender. Can I click OK?
Yes.
Yes, sir.
Okay. So can somebody tell me what is the mean age of male? I mean, what is the mean income? How much are they earning?
46,533.
Thank you. Is that the LRBC?
Yes, ma'am.
Thank you. That's okay. It's the same person that the Abraham, right?
Yes, ma'am.
Mr. Babatunde is on the field and Mr. Niela too. Okay. What about Mama Jingo? Is she there?
Yes, I am.
Okay. Are you getting it, ma?
Gradually.
Gradually. Okay. No one. So what about the mean age for female?
51,533, ma'am.
Okay. On average, for both male and female, what is their mean income?
12,000. Oh no, on average.
Average should be 49,033.
9,033 naira.
Thank you. So this is correct, Abi. And even from the calculation this table is giving us, you can see the difference between these people income is 5,000. There's 5,000 naira difference.
Do
you see in this thing? But is it statistically significant or not?
It's not significant.
So who disagree with that result? That is significant. Did anybody disagree?
It's not significant too.
So it's not significant. So there's no difference between the average income of male and female. So that is it. But if we are doing, okay, it's not significant. So you see that there's no difference. So are we good? Can we proceed?
Yes.
Yes, ma'am.
So that is that. We have done that. What's the next thing? There's another one that we can compare. So I want us to stop there so that we will not rush. Okay, you see, it is the rule is still the same thing. If it's less than 0.05, then there's difference between their age. We have also used income to test. Now for chi-square test. Now you see this chi-square test is also a test of hypothesis. Then we have ANOVA. Yes, we have ANOVA too, which is the common one. You see this chi-square, t-test, ANOVA, they are very common. When do you suppose to use chi-square? You will use chi-square when you want to compare two categorical variables. We've talked about categorical variables, abi? Somebody should give me.
Yes, ma'am.
Okay, I will move to this place. We have age, income, sex, education. Let me look at how that education is. Okay, education is in year of schooling. So who can tell me, like, how many categorical variable do we have here? Even though it's all of them are showing number. How many categorical variable? Mention the categorical variable that we have here.
Isn't it age, sex, income, and education?
They are not in category. Which one is in category, please?
The
Income,
categorical
income now.
variables are sex. Sex is categorical. Education is categorical.
What are the category of education that we have? eh?
Education is a categorical variable.
We have 9, 11, 12,
I
12,
think
14, 15.
the highest number is 16.
The highest number is 16. So how many categories do we have here?
1, 2, 9,
That's 7.
Sir?
10.
7.
We have 7. Okay. So for chi-square, we are going to use chi-square when you have chi-square is used when you have two categorical variables that you want to compare. But for ANOVA, you will use it when you want to compare the mean of one continuous variable and across two group or more. I want us to stop here and I will do example. For example, if I have marital status and I want to relate it to sex, we'll do the same way. Please, let's look at it. We'll click statistics, summaries, table, test. Then I'll pick tables. You will pick two-way tables with measure of association. Let's do it. You know we have two this thing here. Statistics, summaries. Where is it? Then I'm going to pick table.
Table of
Let me see. This is not what I want. Combine later. Frequency table, yes. So
Vegetables.
yes, frequency
Okay.
tables.
One-way table or two-way table?
It is two-way.
table with measures.
Two-way, it's two that we want to compare with the measure
Yes.
of association.
Mm-hmm.
You will then pick for the row. What are we comparing? Sex and marital status, abi? We do not
Yes.
have marital status here, but I want us to improvise. Come. I want us to improvise.
Sex and education can go. I don't know.
Education is having many. It's looking like numerical. That's the thing.
Okay.
You see, it will be too. Even though it's like they are 30, like there is too much. It's too
The
much.
numbers.
Mm. It's too much. I can generate, abi?
Sorry, what do you press on the column variable?
What did I press? That's where I put education.
You just put education there.
Mm. Let me I've taught us how to I want to generate. I want to put this education into two. Let me sort it. I don't begin the right code again. Data. Sort. I want to sort education. So as a data analyst on your own, then I want to browse it. There are some things that you will look at. Now I have, if somebody spent 8 years in school, that is
Hmm.
like secondary. Is that secondary? Primary is six, right? Secondary school you will use
Yes,
6 too, it will be 12, right? So I'm going to
yes.
categorize this thing into secondary and higher degree. I will do secondary and post secondary. Is it good? Do you see anything that is greater than 12? That means the person graduated secondary school. So I'm going to do secondary and post secondary. Yes. Are you with me?
We are with you.
Yes.
I want to do
Second,
Yes,
gen.
ma. Yes, ma.
I want to do edu. I'll just call it level. Yes. Equal. Let me see. Hey, why did I use point and click again? This is what
What is
I want to
what
use
is
point
that?
and click to generate. Let's create.
hello, ma. Sorry,
I'll
ma.
yes, sir.
Yes, this table that is under the output, the results.
Hmm.
I didn't understand the way you got the
Is it
results.
this one? This one.
Yes, the two-way table that you just did. Yes, ma'am.
Okay. I click statistics, summary, frequency
Bingo.
table. We want to look at association. Chi-square measure association is a way to test if there is association between two categorical variables. You can check it. Why? When do you use, what is chi-square? Chi-square is what we use to test if there is association. When you are talking about relationship, you are talking about regression. But this one you want to know is an association that you want to test. Is there any association between two categorical variables? So do you see what I click? I
Yes,
click
ma'am.
this and I pick sex. I put this here. I supposed to even click this piercing, because that's what will give me this thing. Oluwa. Mm. Okay. But let me just generate that one. Mm. This is the chi-square contribution. This first one. This one is this is the frequency. It's saying you have one in this category, 2, 3. It's not making sense. Let me categorize them. I'll come to data. I'll create new variable. Then I want the name to be education, edu level.
Yeah.
Hmm? I can create expression that I want to do. Equal to, where is that equal?
Sorry, from my own side here, I'm having two tables on the education.
Uh-huh.
Yes.
You're
And
having
I
two
can
table
see
too.
yeah, and I can see you're having just only one table, but yeah, I'm having two tables here.
I'm coming. I'm coming. Okay, I'm coming. Equal to, where did I see? I wrote rubbish. Why are you having two tables, please?
I'm equally having the same thing as you just said.
Oh yeah, tell me what you click. Let me click the same thing. Summary,
Uh,
descriptive.
mm-hmm, mm-hmm.
What do you click? Frequency, two-way.
Mm,
Are we good?
yeah, yes, I think yes, yes.
Uh-huh. What do you press? I pick
Uh,
sex, yeah.
yes. Education the other way.
Education.
Okay.
Even if
You
I did
click
not click this, I did not see. Even
Yes,
the
just like
first
this
one,
now. Just like this. Okay.
like this, Abi, I should click
okay.
OK.
Yes.
I'm having one.
Ah.
Wait, in your what do you have here in this place? Tables, tablet,
Mm,
sex, education.
1 second.
Yes, under the section, I'm having two as well.
Tablet sex education. That is what I have.
And you're having two tables.
Mm-hmm.
Yes, ma'am.
Oluwa. Share okay. Let's use that one to close. Can somebody share this thing for us? But please, I want to generate education.
Generated already. Gen edu underscore level equals null. Equal point. Full stop. 30 missing variables generated.
You do understand.
Somebody is saying I do not understand. Please, who is the person? Which one? Please. Which one, please? Do you notice what happened here? When I was writing the expression, when I say create, and I come here, I pick this, and inside here, instead of me to the expression that I want
Okay.
it to be, maybe I want it to be 1, or I want it to be missing. I went ahead to still write equal. I wrote equal because this thing is going to put equal again. That's why I have this. Something like this, and that's what gave me error. I'm supposed to put what I want it to be. So let me stop sharing. We'll close here. It's already 10 for those that have other engagements. So I want to appreciate everyone here. God bless you. Thank you for coming. Next week, please, let's join on time. I say next week. On Saturday, let's join on time, and I will want to beg us. There's a meeting that I normally attend. I'm the secretary. There's a grant this thing. Even though I normally take permission from them when I will not be around, but I don't know what is going to happen next week because we are rounding up that project. We'll be in class, but if they need my attention, I will take permission to quickly attend to them. It will not that meeting don't take more than highest 20 minutes. So please let me beg us ahead of time. I'm still recording so the other people that join next week will understand that I already seek for permission. So please, do I have you people's permission? Please.
Yes, it's okay.
All right, ma'am.
Oh, why not? Why not?
Yes.
Okay.
You do.
Now, will you be able to send this one
I'm
record to
sending
us
this one
again?
to us now. I'm not editing. Everybody edit
Oh,
on your own.
okay.
Ah.
You know what
Thank you.
happened? The people that used to that edit for me, if you know how much they are charging me, this one is 2 hours. So they were charging, I said, waiting. So I was the one that would sit with it. Some days I spent 5 hours. But it is well.
Wow.
I will send it like this. So
It's
thank
okay,
you
ma'am.
so much all.
It's
But
okay.
don't go. If you have question, please wait.